Hi, everyone, and thank you for giving me the opportunity to give this Ronin Institute lightning talk. The purpose of this talk is to quickly introduce myself as a new member of the Ronin community and to tell you about a book that I'm planning to write for the general public, which is part of a project, a research project that is currently running hosted at the Department of Philosophy of the University of Vienna. I am by training an evolutionary systems biologist and developmental biologist. I am an empiricist with experience of running a lab, but then also mostly a theoretician. And in particular, I am trying to do a kind of evolutionary biology that is interested in conceptual and philosophical questions. So over the past few years, I've been increasingly publishing papers with more philosophical content. I'm passionate about open science. I am a freelance scientist, educator, and philosopher, and I'm currently, as I said, a project leader at the University of Vienna. Also very important to me is mentoring of students and education. So if you're interested in these kind of problems, I think education of scientists nowadays is very problematic. Producing a number of highly technically skilled specialists, but no longer people who can think about the questions they're actually asking. And so what I really want to be, what kind of summarizes all of these different terms here, is a natural philosopher. I think really in this century, we need, because of the fragmentation of all the sciences, the disciplines, the research disciplines, we need a sort of a high-level view. And we need to ask ourselves and reflect on what are we actually doing as scientists? What is the societal function of science in the 21st century? And are we fulfilling that function at the moment? My personal history has taken me many places. I'm originally from Switzerland, from a little village called Tschirchen, which is on the left upper hand corner. And I'm not trying to show you pretty pictures here, but sort of I want to highlight that I went from a fairly conventional biological education as an empirical biologist in Basel, in Cambridge, in Stony Brook, to first a mathematical theoretician in biology. So I was studying the evolution of gene regulatory networks in different species of flies, and then as a group leader, and later on as the director of an Institute of the Philosophy of Biology, increasingly as a sort of a theoretician in the sense of philosophical biology. I'm going to tell you in a minute what that is all about. The starting point for this whole story that I'm going to tell you today is during COVID, I was giving a lecture to about 12 master students at the University of Vienna every year. And because it was COVID and I was locked down and I was recording the lectures anyway, I decided to put them online. The series is called Beyond Networks, the Evolution of Living Systems, and it's been a surprise success because it seems to address problems that go across the specific disciplines that I was trying to address. It touches on problems like the formal approaches, networks, especially in biology that we have. It touches on how we use reductionist approaches and where they fail and so on and so forth. And I used it as a starting point to think more broadly about the limitations of the methodologies I was using, which was mainly data-driven, quantitative microscopy, and modeling using dynamical systems theory, and whether those tools were appropriate to study biology in our times. And this step-by-step led to a project that is funded by the John Templeton Foundation. It's co-led by Professor Tarja Knutila, who's the Philosophy of Science chair at the Department of Philosophy in Vienna. And it includes a senior postdoctoral collaborator, Andrea Lutgers, 2 PhD students, Paul and Kevin, and an outreach curator, Bashak Shenova, to investigate 3 main pillars, basically, of how the nature of organisms influences the dynamics of evolution. Okay, so the central idea here is that organisms are unlike machines, unlike mechanisms. They are agents. And it tries to ground this insight in naturalistic explanation and connect it to what people do in the lab. And we do this based on three main pillars of the project. One is we examine the philosophical foundations of evolutionary process. We think about what would a scientific methodology look like that takes these issues of agency, evolution, and emerging possibility space serious. And we're trying to do a very big effort in outreach and integration to explain these very abstract concepts and problems to a broader public. So a bit more detail. What we're trying to do is we try to look at notions of emergence and complexity and try to argue that what we need is a processual approach that looks at new emerging levels of organization, not just computational complexity in living systems. We need a new notion of possibility spaces, of defining probabilities that arise during an evolutionary process, at least partly due to the actions of agents. And we need, and that's very important, no synthesis in evolution, but a perspectival approach, because evolution is the process that creates diversity, and we need to look at it from many different angles. In terms of the scientific methodology, we're looking at the ways in which we formalize living systems and where these approaches break down these formal approaches. We look at how to represent and model autopoiesis, teleodynamics, which are all words for the goal-oriented self-manufacture of organisms. They're organized in a way that the primary goal is to continue living. This is meant by teleodynamics. That's a word invented by Terence Deacon, and autopoiesis, Maturana and Varela. And we look at the way these systems are embodied, how they do not break any laws of physics, and yet can not be explained just by the laws of physics alone. So it's an emergentist approach that we're taking here. And for the outreach and integration, we are propagating something that we call Wissenskunst, which is a sort of a playful engagement with philosophical and scientific ideas. And we try to look at using art at those parts of the world that we cannot put into well-defined syntax, the undefinable. And then there's the book project, which is the central topic of this talk, where it's called the Beyond the Edge of Machines, where I try to explain that modernity basically is coming to an end. Modernity is the age of the machine. So it's the age of looking at the world as if it is a machine. And this is a collaboration with artist Marcus Neustetter, who's made all the drawings that you will see in the remainder of this talk. So this book, it may be a little absurd to write a book right now when AI and everything is coming online that is called Beyond the Age of Machines, but it is really about a philosophical outlook on the world, and that we can no longer treat the world as if it was controllable and predictable, which we are doing right now, and which is underneath many of the problems that we are experiencing in what has been called the polycrisis or meta-crisis of our times. To give you a very quick sneak peek of what's in the book, we put up these 12 theses, with apologies to Martin Luther, that dispute the power and the efficacy of the machine metaphor in science. And they think about a science that no longer looks at the world as a machine. And those 12 theses are as follows. The age of machines, that is modernity, is coming to an end right now. The world is not a machine. It is not even like a machine. And so even using this idea as a metaphor is no longer useful. The world is large. It far exceeds anyone's grasp. And by large, it's not just spatially rich and huge, but it's also a world in which few of the problems that we encounter are well defined. We are ourselves not machines. No living organism is a machine. From bacteria to humans, we are organized in an extremely different way than any machine any human has ever built. The world, as a corollary to that, is not a set. There are strict limits to what we can formalize. Okay, we cannot come up with an itemized sort of representation of the world. Organisms constantly create meaning by engaging the world. You have to be in the world, embodied in the world, to generate meaning. To engage the world is to solve the problem of relevance. So you need to pick out of that large world the problems that you want to solve, and you need to define them. And that is a problem that is not computational, is not algorithmically definable. To solve the problem of relevance is to formalize the world in the sense originally used by Hilbert of turning ill-defined problems into well-defined ones. And everything that makes sense to someone. So you have to be someone, an organism, not an algorithm, to make sense. There is no meaning without life, therefore. There is no meaning without self-preservation. If you do not have autopoiesis, if you do not have self-manufacture, if you do not have to do constant work to keep yourself alive, there is no meaning. There is also no meaning without death, without suffering, without having to prioritize. And to be a true realist means to acknowledge all of the above. So this is supposed to be a new naturalist approach to science itself that is based on what we know today about ourselves and the world we live in. The idea is to go and print this out and nail it to all the university doors around the world, because we need another scientific revolution nowadays. So to summarize, we have a little manifesto in the book. One is we live in this kairos, this turning point, which is both a crisis and a chance. In times like these, the agency of the individual gets maximized. And this tells us also something about the role of agency in evolution. Wisdom. We need to not just know more about the world, we know enough to act with wisdom, but we do not act that way. So that's also what's meant by embodiment. We need to be able to actually implement. And by Mysterianism, I mean just the simple acknowledgement that we cannot control, predict, or know the world completely. It is large, it is beyond our grasp. So we have to be chasing windmills when we try to understand the world. We have to do 6 impossible things before breakfast. In the end, the idea is not just to deconstruct and criticize modern science, but to come up with a reconstruction, a meta-modern version that comes after the postmodern criticism of science and our age, that rebuilds what has been deconstructed. So to summarize all of that, the message of the book will be that we must stop ceding the agency of humans and other natural beings to machines that have none. If we want to face the crisis that we're going to face in the next few decades or centuries, we have to take control again, instead of giving away our agency bit by bit. So the book is being published online. I'm writing it as I go along. There are feedback sections at the end of every chapter. You can find the book website on our project website, expandingpossibilities.org. My personal website lists the kind of courses, philosophy courses for scientists, and a workshop called Surviving and Thriving in Academia on my personal website, and then the Arts and Science Project with which we do the outreach is hosted at thezone.at below. And that is all I wanted to say. Thank you very much for listening.